couple of questions that I've received from the VL for absolute value and equations and inequalities. So, and let's see, let's write that down. So the VL for the absolute value equations and inequalities. Okay, so in particular number 4, and the way this question looks, let me pull it up for you real quick. Okay, here, let me find it. Okay, so let me pull it over to this screen so you can see it. But it kind of asks you to work backwards, and I think that's why some of you are having trouble with it. But if you, so it's this one, let's see, where is it, number 4, where you're provided a graph and then you're asked to come up with the absolute value inequality. So again, that means that the inequality that you come up with has to have an absolute value expression, right? So you could come up with an inequality that represents the shaded area, but this one in particular has to have absolute value in it. So a couple of different ways to look at it. So if you think about it, we know that absolute value in general means distance from 0, right? So like if I was just going to say the absolute value of x is less than, let's say 3, right? So really what that means is that if I'm looking on the number line, here's 0, and then I could go 3 units out in either direction, right? So to 3 or to -3. Since it's less than, that means the distances from 0 that are smaller than 3. So that would be any of these. We would use the round parenthesis because of the strict inequality, right? And then we could go in either direction. So that shaded region, the absolute value inequality that would represent that would be the absolute value of x is less than 3. So when you're looking at something like the problem in WebAssign, like the one here, we're not looking at just the absolute value of x, but where 0 would be the center, we actually have that shaded region switched one way or another. So for example, I'm just going to create some different space. Let's say, I'm just going to kind of draw one myself. Let's say I'm going to put 3 in the middle, and then let's maybe go 2 units to the right and 2 units to the left, so 2, 1, right? And I'm just going to draw a similar picture, and then we'll shade it. So just like the one when we were comparing with 0, I want to find the middle of that shaded region. So the middle is 3. So actually I'm looking for the distance from 3. So since to go from 3 to 5 is 2 units, or to go from 3 to 1 is 2 units, I would say again that the distance from 3 is less than 2. And so what I would say is that x minus 3 in the absolute value is less than 2 units. So again, like the one over here in WebAssign, I would pick out that 4. 4 is the middle. So this is, if I pick out the middle, it's 1 unit to get to that endpoint on the right, 1 unit to get to the endpoint on the left. So if the middle is 4, I would be thinking the absolute value of x minus 4 is less than, then again, this distance, which in this case is 1. So these could also be greater than inequalities. So if you had a region that was shaded, let's say, let's say we'll make this 1. And then let's go 3 units. 1, 2, 3. So 2, 3, 4. So that would take me to 4. But let's shade this way. And I'll use a different bracket too. I'll use the square bracket. And then we go 1, 2, 3. And we'll go like this. Okay, so that would be what? 2. That's 1. That would be 0. I can't think now. So this would be 0, -1, -2. Okay. So the shaded region now are on the outsides of the number line. We still want to find the middle, right? We still want to find the middle, which would be 1. So I'm looking at the distance from 1. So to get to the bracket, I have to go 3 units in either direction. But the distances that are shaded are more than 3 units away from 1. So I would say, again, since 1 is my center, this is the absolute value of x minus 1. But again, since this shaded region is greater than that distance, I would use greater than, and this time I would use or equal to because of the square bracket. And then again, it's 3 units away. So that's the way to think about those. And I hope that helps.